Thank you. I'm going to talk about Scala. One of the things I would ask you to do is to ask a question anytime you have one. Best time to ask a question or make a comment is when you have it. So don't wait until the very end. I'm going to talk just a little bit about Scala. Maybe you'll hear me talk for about 5 minutes or so. And then I'm going to sit down and start writing some code. And we'll kind of take the code along and see where it goes. So the first question, of course, is, why do we care about Scala? Why should we be interested? I'm sure there are a lot of stories as to why we should do something like Scala. But what excites me about Scala is about a certain number of things that has happened around us. We are not in our father's environment anymore. Whether you like it or not, you've been dragged into this war of multi-core processors. And essentially what this means is that writing multi-threaded application was already hard. On a single processor, multi-threading is more multitasking. And let's give credit where it's due. Java did something wonderful. Probably a lot of you are old enough to remember this. When you program in a language like C or C++ or even languages before, you just could not use the same set of libraries to write code. And if you had to write multi-threaded code, you had to switch to a different set of libraries. It was painful. So what Java did really wonderful for us was it gave us this beautiful concept of write once, run anywhere. Or some of us like to call it as write once, debug everywhere. But the beauty of this is we were able to use a consistent set of API across these different platforms, and that was great. But when everything is said and done, what we have on our hand is a fairly low level of abstraction. And when you are dealing with an object, we had to deal with thread safety. But that was only half the story. Then we had to deal with visibility of data. Certain change done by one thread may not even be visible to another thread for a long time or for never, for example. We had to deal with concurrency. Thread safety and concurrency, what's the difference? Thread safety is to protect it. Concurrency is to make it available. And that was pretty hard. So eventually, one of the feeling I developed was that if you want to create a multi-threaded code in Java, you got to be God. And I'm not one. I'm a very mortal human being. It's extremely difficult for me to manage that level of complexity in creating application. Now, where this gets even uglier is that now we have multi-core processors on hand. And now multi-core processors, threading is on steroids. We got many threads attacking this object or data. And how do we handle this? So what we need is a higher level of abstraction. I got an email from a guy, and I thought this email was very funny, but I'm sure he didn't think so. And his email said, hey, Venkat, we got this application. It works fine. But last month, my company deployed this application on a multi-core processor, and all hell broke loose. And then his email goes on to say, don't tell me to do the right thing because I already know it and I cannot do it. What I want you to tell me is, tell me the quick fix. What's the simplest thing I can do to get this application running on this multi-core processor? And I wrote him saying, oh, it's very simple. Just walk up to the machine and turn off one of the cores, and everything will work fine. And the point is that we cannot just deploy applications and then expect them to work. It is going to be incredibly hard to get them right. This is where we need a solution. But here's the good news. The solution has been around for 50 years. And I say that's a good news because I'm not a fan of trying newfangled things. I don't want to come here and say, hey, look what we found yesterday. You want to give it a try? No, we got businesses to run. Corporations cannot rely on something that's newfangled or discovered last night. This has been around for 50 years. Academics has worked on it. There are research projects that's been on this. And there are commercial tools and languages on this. The only difference is that these were not available on the JVM, the Java Virtual Machine. So what Scala does, I call Scala as an old wine in a new bottle. It really brings well-proven practices and methods onto the Java Virtual Machine. And the beauty of this is you can preserve your investments on the Java Virtual Machine. You got applications running on the JVM. You don't have to toss them out. You got libraries built on the JVM. You don't have to toss them out. You got experience built upon the JVM. You don't have to toss that out. But yet, sitting right where you are, you could still reach out to some of the capabilities of this functional style of programming and make use of it in the Java virtual machine. And that's basically why Scala exists. It is to give us the power to contend with this beautiful power we have on our hand in a prudent manner. So Scala is really, essentially, when everything is said and done, is simply a language on the Java virtual machine. It's a language that's not fully functional, though. I would say it's a bit more pragmatic. While functional programming is extremely powerful, I'm not a fan of all or nothing proposition generally. While that may be great for most of the things, doesn't mean it's great for all of the things. So what Scala gives me ability to do is to mix and match based on my desire and the needs in my application. So think of Scala as a dial, like a radio dial. You could take this all the way to the left, and you would be doing imperative coding like you are used to in Java. Or you could take this dial and go move it all the way to the right, and you could be doing functional programming like you do in Erlang or Haskell and so on, for example. So you have this power of selecting whatever is your comfort level in terms of the programming style, and you can pick and choose what makes the most sense. So what's really special about Scala are quite a number of interesting things that really Scala offers for us. One of the very first things that you will notice with Scala is conciseness. Now, a lot of languages are around there, but languages like Java, remember the time when Java started out as a simple language? I'm sure most of you read the book that said Java is great because it's simple. And I call this the politics of programming languages. The guy who wants to run for office, what does he say? He says the current government sucks, bring me to power, I'll make your life better. 4 years later, the same thing we hear, but just the other guy is saying about the guy who got elected, right? So Java said, look, if you want complexity and you want to contend with it, be happy with C++, but if you want simplicity and productivity, come over here to this beautiful world of Java, we got it here. And then what happened? Now that you come to power, we forget all those things, right? And slowly we got put more features into the language, and all of a sudden, Java is no longer a simple language. It's verbose. It takes enormous amount of time and effort to get things done, and we got to write 20, 30 lines of code to even accomplish simple things. And so what we want is, if you think about this for a second, there are three things that are interesting on the JVM. The platform, right? The Java platform. And don't underestimate that. That's where the real power is. The Java platform has come a long way over the past 15 years. It's one of the most powerful platforms out there, improved several times over. And then the next thing is the Java API, the JDK and the libraries that's ubiquitous and powerful. And then comes the last one, which is the Java language, also known as the weakest link. So the language has become the weakest link of these three things, the Java platform, the Java API, and the Java language. And why not simply reach over and use more better languages so that we can make better use of this powerful platform and powerful library? And so when you program in language like Scala, you are programming the Java virtual machine. You are using the JDK. You are using your Spring libraries and other libraries that you create, and yet you are using a language that gives you not just the syntactical advantage, but also a different style of programming that will leverage the underlying platform in a much better way for us to be more productive. Enough talking. Let's take a look at an example and see how this would work. Let's talk about writing classes. That's one of the things we all do as programmers, and especially Java programmers, right? So how would I write a class? Let's write a class called, public, let's say, a car. I want to write a car class or a stock class, doesn't matter what you write. And then what do you do next? You say public class car. Stop right there and think about it. How many times have you written a class that doesn't have to be public? Kind of makes you wonder, isn't it? You say this every time, or at least most of the time, 99% of the time. And yet we kind of chew the gum and say that's life in the big city, that's the way we got to write it, and we end up keep writing it, right? And then we want to write maybe a year. So I say what? Private int year. And then you say, oops, I forgot, I need to say final. Why not final be the default? That would make life a lot easier, right? So we tend to forget that. Then I'm going to say private int miles for the miles of the car. Now I got to say public int get year, and then of course this has to say return year. Then I've got to write, public int, get miles. You all know where this is going. Then you have to write the set miles method. And then once I finish writing the set miles method, you remind me that I forgot to write the constructor. But you know what? It's already time for a coffee break. I'm tired. You may argue, hey, Venkat, come on, grow up. You don't really type this code. We got fancy IDEs to do this. I would be in this beautiful Eclipse or IntelliJ. I'll click on this button, and there the code just appears in front of you. Think about that for a minute. Do you want a complex language and then complex IDEs and tools to manage it? Right? That doesn't make any sense. I don't want to see that junk in front of me. Even if IDEs do it, that's called IDE vomit. I don't want IDEs to be vomiting on my code. I want to clean it up, get it out of my sight. I don't want to see it. Why? If I don't see it, I don't have to maintain it. If I don't see it, it doesn't distract me. So I want these things to work automatically behind the scene. And I didn't even write the constructor in this code, as you can see. But I'm going to write exactly that code with the constructor in Scala. And how do I write it? So I'm going to say class car. And I want this to be integer, but I want this to be a final value. Val year is an integer. And I said it's a val, it cannot change. Var miles is an integer. So notice that I wrote this class and I declared that the car has a year and miles. What else? That's it. You say, hey, wait, I need to declare year as final. You did. I want to declare miles as a variable. You did. I want a getter for the year, but no setter for the year. Done. What about miles, a getter and setter? Done. What about the constructor? Done. What else can I do? Go home. Take a break. You don't need to be working hard to do stupid things. You wrote a class, it's done. That's conciseness right there, end of story. So for little things that we do, we don't need tools to do things. Languages have to absorb those things for you, and that's exactly what this did. By the way, if anybody is courageous enough to sit in the front row, there are seats available here. I don't know why everybody wants to go back, but that's your choice. It's here if you want to come down here. I'm a good guy. I don't get hostile. Yeah, please.
Is explicit setter and getter, is it prefixed with get and set, like bean convention?
Very good question. So Scala doesn't believe. Java Bean is such a sad story. Java Bean was, the day they announced Java Bean, they said, hey, you are not just a Java object, you are a Java Bean. The Java Bean is like, really? What does that mean? Well, you have properties. And the Bean got excited. It's like, cool. What are properties? Well, you got a field and you got a getter and setter that follows a special convention. And the Bean was about to open the bottle of wine. But it said, but how do people talk to me? Well, by calling the getters and setter methods, of course. And Bean was in depression ever since. It's like, you cheated on me. This is no power at all. I'm just another object. You're just putting lipstick on the peg. Scala said, enough of that. No need to do any of that. Let's just make this getter and setter, call it directly as a property, and we'll deal it as a property. So the answer is no. Scala doesn't bother to follow Java Bean convention. But you say, okay, that's cool, Venkat, but I do need to follow Java Bean convention because I got some Java code over there that needs to talk to my class. No worries. You can put a Java Bean property annotation on the property, and then Scala will spit out the getter or the setter as appropriate. So you can make it do it with a little price, but it discourages you from doing things that doesn't make any sense. Please.
So in Java, you have the ability, whether it's a good practice or not, to create multiple constructors with different arguments.
Oh, awesome question. This is even better. So the question is, hey, in Java, we create multiple constructors. How do we do it? Pretty good question. Because I said the main constructor is already over. So stay with me for just a second. I'll come back to it. Because all this doesn't matter if this code doesn't work, right? So let's go ahead and give this a shot. So I'm going to say val car equals new car. And I'm going to say this was created in 2010. Let's say the miles is 0. I'm going to print car dot year to print the car's year. And I'm going to say print car dot miles to print the miles of the car. So it's just a little code I wrote. And you can see it printed the year, it printed the miles for you. But it also wrote the constructor for you already. What's really cool about this is I could put methods here. I could say drive, and I could say distance, which is an integer. And I could basically say here, I want to drive this the distance that was given. So I could come here and say car.drive 10. I'm driving this car 10 miles. Now I say car.miles and print the miles. It better have moved 10 miles, and it did. But what's interesting though here is the code you put within the class, as you know, belongs to the class. However, rather than writing functions, if you start putting statements within the class. So I'm going to say here, creating car. Now when I run the code, notice that it called the creating car. So in other words, the code that you stuff into the class becomes part of your primary constructor, which even aggravates your question now. Okay, then where is the other constructors? So Scala has what's called a primary constructor, but it also has those called auxiliary constructors. You can write as many constructors as you like by writing methods within the class. So I could say I want to give maybe a year over here, and then maybe the miles is going to be assumed to be a 0. I don't need to give the miles maybe. So I could write code like this. But then here what I could do is I could call back into my primary constructor, if you will. But what Scala requires you to do is that in order to avoid redundancy of code and also errors that result from it, all the auxiliary constructors are required to go through the primary constructor. So Scala streamlines the way you write the code, avoids duplication of code, and eliminates bugs. Not only that, if you inherit from another base class, then all the calls to super can only go through the primary constructor. So that again channelizes calls in a proper way so that it eliminates these errors that can normally happen in the code. So you can have primary constructor and any number of auxiliary constructors in the code. It's a good question. So that's basically what's provided for you within Scala itself. So you see how the classes are really cute when it comes to writing these. It doesn't take a whole lot of effort. It is concise. So you can see that the code is very elegant rather than introducing ceremony. Now you may look at that code and say, yeah, but that syntax looks alien. I've never written code in any language where the syntax did not look alien. Every language syntax looks alien. But then once you dip yourself into it for about 2-3 weeks, you don't even think about it anymore. So never let a syntax of a language scare you away, unless it's Perl. That's a different question. So don't let a syntax of a language scare you ever. Just kind of engage yourselves in the idiomatic differences and the benefit it provides, and don't worry about the syntax, because syntax will look alien to you no matter what, because you're so used to a certain language and your brain just cannot parse anything else until you get used to it. So don't let that dissuade you from looking at a language. But Scala also has a pure object-orientedness. What does it mean, pure object-oriented? Well, Java gives you this split world where you have primitive types and you have classes as separate from each other. Well, the problem with that approach is you got to be inconsistent in your APIs quite a number of times. Let's think about this for a second. If I were to write a Java code and I'm going to say print line 1.toString, of course in Java you'd probably say system.out.println, but if you say system.out.println 1.toString, what do you think is going to happen? Error, right? In Java you'll give an error because you cannot call toString on 1 because 1 is primitive. You cannot call methods on primitive types. Whereas here in Scala, I'm going to run that code and notice how it printed 1. How did it know to do that? So in Scala, everything is an object. There's no such thing called primitive type in Scala. Everything is an object. You say, oh, that's cool, but what about performance? If I'm going to deal with everything as an object, am I not going to lose performance? You could, but the guys who wrote Scala are smart. They said, if this object is not being used as a real object, in other words, if 1 is being used as an int all over, then very quietly it will generate the bytecode where it simply becomes a Java int under the hood. So there was no degradation in performance at all in that case. If you are actually calling a function on the number, Then it realizes, gee, this is not a primitive anymore, this is an object. So at compile time, it converts the number into what's called a wrapper object, in this case a rich int. Rich int under the hood converts back to the primitive integer at the bytecode level. So you got the best of both worlds. You got fairly good performance on hand, and at the same time the convenience and the consistency of treating everything as objects in your code as well. So this gives you quite an advantage in writing code. But remember one thing though, even though you are using a different language, you are still working on the JVM. There's only one true language on the JVM, right? That's the bytecode. So all this gets converted to bytecode at the end of the day, and so it's all bona fide Java code, where the Java is not the programming language in that context, Java being the platform in that particular context. So they run under the hood. So it gives you pure object orientedness. Now not only that, it means that as a result, Scala does not have any static methods. No, there are no static methods. I know some people are willing to leave the room at this point. It's like, no, please stay tuned for a second. It's even better. There is no static methods because static methods are evil. Have you ever, why is it evil? Because it's hard to test it. The context is hard to understand. It is there all the time, but in a JVM running in a web environment versus desktop, it confuses the heck out of us. Have you ever, any of you had an opportunity to teach Java to somebody? Those of you know the pain. You bring these captive audience and say, Java is a simple language, listen to me. I'm going to show you a simple example. What do you do then? You say public class hello world. And the audience is like, excuse me, what is public? The other guy is like, what is class? They don't ask you hello world. That's bad students in the room if they did. But they ask, what's public, what's class? You say, you know what? You don't need to know that right now. Let's move on. We're writing a simple code after all. Then you say public static void main. That's it. Okay, now I want to ask you what public and class is. What in the world is a static? You don't need to know that. Let's move on. And then when you finish writing, they're really scared. This is simple, but there's a lot of things I should not know, right? It doesn't have to be. If the language is simple, it's got to be simple. Just say print line, that's simple. There's nothing more there that you don't need to know. So don't write a lot of junk and say, don't know that, and then it's simple. It's not really simple. That's just cheating. So in the case of a class, classes represent abstraction for an instance. So you say class car, and I'm going to simply put whatever is the content of the car, year, miles, and so on, don't care. But I want to know how many cars I have. Maybe Toyota is interested in knowing how many of them are there out there. How do I know how many cars are out there? Well, what do you do normally in Java? You say define or public static int get count, right? Remember that? Well, here you say object car. So notice how I created an object car. What in the world is an object car? Only look at this code for a second. Don't go anywhere else. That is the way you create a singleton in Scala. What is singleton? Most of you probably know what a singleton is. But in case you don't know, a singleton is a pattern that you take 5 minutes to learn and 6 months to get it right. It takes an enormous amount of effort to get it right. People do it wrong several times over. The fun with singleton is go to somebody's code and say, I got a singleton. And then you say, does it work? And he'll say, of course it does. And then point out one problem. And then 2 weeks later, another one. 3 weeks later, another one. It's so hard to get it right. What is one of the best ways to get the singleton taken care of properly? To leave it to the class loader. Class loader is the one particular thingy that can load up a singleton properly for you. So even in Java, the most recent recommendation is to let singleton be handled by the class loader. Scala said, if singleton is so important and common, yet we keep messing it up, why not make it a language feature? So singleton is a language feature in Scala, and that's how way you write a singleton. This is one instance of this class that gets created that represents the class, not the instance, but it's a meta class, right? It represents the grouping of concept you want to put in the class. It's a one instance of something that it creates. But then, notice I also have a class called car and an object singleton called car. When you have a situation like this is not called a singleton, this is called a companion object. So while your class holds the details of an instance, the companion object ends up having the details for the class. So what I would do now is I would say define instances count, or maybe count instances, count of instances. And I'm going to write a function here that's going to keep track of these instances. If you want to wire yourselves into a Java way of thinking, count of instances is a static method. So in other words, whatever you would have put in a class before, you still put it in a class. Whatever you would have put as a static method in a class before, now you move it over to this companion object. What is that called? It's called separation of concern. You are able to focus clearly on one thing and one thing well. When you look at a class, you're not juggling between instance variables and static fields, and instance methods and static methods. You focus on the class, you got one view of the abstraction, whatever makes up this object. If you want to deal with something that belongs to the class itself, move over to the companion object, and that has the methods and stuff like that that needs to be in the class level, and so that manages that. So it's a very nice separation of concern that Scala provides for you. Please.
Is that easily mockable in like mock frameworks too, the object class?
Because they are objects at runtime, so they can be mocked away fairly easily as well. Absolutely, great point. And that is something that favors testability quite a bit, right? And so that is something to think about. And static is hard to test, whereas because it's an instance you are dealing with, you could mock away and stuff like that. That can be done pretty effectively. So it's a very nice way of dealing with pure object orientedness provided by the language here for us. You saw how that would work and manifest very nicely. Now there are quite a number of things that are optional when it comes to Scala. One of the things you did not notice me do over the last maybe about 20-30 minutes is what? I never hit the semicolon. Some of the Java programmers are addicted to semicolons. We are forced to write semicolons. In fact, there is a proof. Just look at your hand. There's a reason why your pinky is so short. It's taken years of abuse of the semicolon, right? But if you really think about it, what does the semicolon do other than hurting your pinky? Not a whole lot. It's a ceremony, which was not needed at all. In fact, semicolons really hurt a lot of things because it introduces noise in the code. When you don't have semicolon, the code becomes light. Let me show you an example here. So if I say class car, and I have a car which is going to have a drive method, I'm not going to implement the method here. I'm going to say drive, and I'm going to say, oh, let's do this. It's even better. Let's say turn, and I'm going to say direction, and I'm going to provide a string for the direction to turn. And I'm going to simply say here that the car is going to turn in the direction. So I'm going to say turning, and turning, and I'm going to simply put the direction over here. That's all I did. So I'm going to create a car. So car equals new car, right? Barring regular Java syntax, you would be tempted to write like that. And then you would say car dot turn, and then you would say, let's say left, and then a semicolon like this. That sounds familiar, right? Scala says, why the ceremony? You don't need the semicolon. So notice I got rid of the semicolon, and the code still works. And then you say, okay, but what's that parentheses doing for nothing? Can I get rid of that? Sure, why not? And the code still works. You say, okay, Venkat, is there anything more we could do? What about this parentheses? What's that doing there? Why don't we get rid of that? Right? So I got rid of that. He was not happy. Because he says, if you're going to remove ceremony, go all the way. So why bother with dots? What does a dot, after all, do? You say, isn't it confusing? It is to you. It is to me, but not to the language. The language says, I know what you're doing, as long as you are okay with it. But then only look at the line number 8. What does it look like? It looks, well, okay, if that looks like English, I want to know which neighborhood you live in. Just kidding. It looks like it looks like data, isn't it? Somebody could give you a stock trading data. They could say stock, a symbol, and then a number of quantity. Notice data becomes code, code becomes data, as long as you don't tell them that. They're okay with it. So you can move towards writing internal DSLs in a very lightweight syntax. So you can suck that line number 8 from a data file and run through it. Data becomes code, code becomes data. And you say, what do I do about all the time and effort I spend in parsing? Enjoy. There's beautiful, weather out there. You don't have to be sitting and writing more code to do stupid things we always do. Languages can evolve to that point. Please.
Regarding the class and object, in Java, you have to have the file name called the same way as the class.
Right.
Does that mean that in this case, the class and the companion object needs to reside in the same file or not?
Okay, so two questions buried in one in your question. Java required class names to be the same as file names. Ask why. For no good reason. I'm not saying that's a bad idea or a good idea, but there was no fundamental reason. The reason really Java wanted that was when you go across the web and ask for a class, they wanted to know which one you're looking at and load it. You know what? That was not a source code issue. That was a deployment issue. And what Java did was it pushed that concern to the code writing time. Bad idea. Having said that, however, in Scala you can put classes in any file you want to. It doesn't matter. I still keep the convention that we followed in Java because it's a good thing to follow for other reasons. So it's a convention, not a requirement at that point. However, if you're writing a companion object, then the companion object and the companion class are required to reside in the same file. A good question is, why? I'm a huge fan of asking this question, why? It's asking why helps us to really get to the bottom, and then we know whether it's essential or it's accidental. And the reason simply is that a companion object can access the private members of a companion class and vice versa, which is a clear break in encapsulation only if it's outside the file. If it's in the same file, you're in the same scope of things you're dealing with, technically speaking, it's much more manageable. So there's a good reason to keep them together for that reason. It's important to ask the right questions and have the right answers. So I'm really glad you're asking those questions because that's the way we probe and find these things. So absolutely great question to have, but that's the reason for having both of them in the same place. Please.
So in line 7, so if you enter a new line after new and move the car to the next line, will the code still work?
Like that?
No. In line after new. So
oh, this one goes over here.
So
okay. So what Scala does is, because you don't have semicolon, yeah. Scala has to do a look ahead, and it does a few interesting things. It says, you know what? You don't have a semicolon. I'm going to continue to read and see if what you are starting on that other next line can be a standalone for its own to begin a statement. If what you wrote can begin a statement, then it will say, okay, then I'll end it here. If it cannot begin a statement, it says, oh, maybe you just split this line into two. I will let this follow through. So, am I making sense? So you will kind of look ahead and say, does it make sense to start the sentence with that? Oh, yeah, it does. Okay, then this ends over here. So it uses some of those little conventions to go through. And in this particular case, you remember this is not Java syntax. In Java, you will say car obj equals. In Scala, that's not valid. So as a result, it says, I'm still okay, because you didn't really finish this statement. You're still going. But don't be fooled by it. There will be times when you think you finished it, but Scala says, no, the other one still looks like it's going to be over here, and it may go against you. So you got to be careful. But that's a very rare situation that happens. So most of the time, if you follow good coding practices, you would never be in confused state with Scala. It'll be quite consistent.
Isn't the word new also ceremony?
New could be ceremony. I like this guy. He says new is ceremonial, Venkat. I don't want it. Is that what you're saying?
Yeah.
You know what? A customer is always right.
Do you need a companion code?
So basically, in this case, unfortunately, because it's an apply method, there is some other convention you have to follow. And as a result, you could ask him, where am I going wrong here? Car and car, I'm applying the new car, define, apply. Let's see where he's erroring out. Let me see. It's a good idea to read the error sometimes. Lower the font and see what he's saying. This dot car of type object does not take parameters. Oh, of course, he doesn't take parameters, but I'm calling the apply method. So why can't you use the apply method? There you go. So the answer is yes, but you had to introduce a bit more ceremony because of a Java convention, but you got rid of the new.
But no, you put the parentheses.
Yes.
Sorry.
No, that's fine. But there are other reasons for it. Because it needs to know whether you're referring to a class or you're invoking an apply method. So there's a bit of a depth of a concept involved in there. If you really still have to get rid of it, there are other ways to do it, but then that's not important for us to do right now. Yeah. So let's talk about imperative versus functional style of coding. What does that mean? Well, let's talk about, let's say I want to total elements in a list. Maybe you got a list of prices and you want to total up what the total price is. That's what you really want to do. How would we do that? So I'm going to say define, I'm going to say total, and let's give them a list. The list is going to be a list of integers. And what does it return to us? It returns a total. So I'm going to say var sum equals 0. Var represents a variable, val represents a constant, or a variable which cannot change. So I'm going to say list.forEach. Actually, let's write it in a more traditional manner. For the value I in the list. And what do I do in the list? Sum plus equals I. And when I'm done, I'm going to return sum. I said I'm going to return sum. But notice I never put the word return, because return is optional. And it's kind of funny, but you may say, whoa, you don't have return? But once you program in this for a while, it feels odd to put return. And I'll tell you, I have to still write Java code from time to time. I'd be writing a Java code, and my mind completely switched over, and I would say, value, and I'll be staring, and the compiler's like, you're missing return. I'm like, what? And then somebody's like, Venkat, you're writing Java. It's like, oh, I'm sorry. And then you put return. So it becomes natural after a while. No need to put return. But I want to total these values. How do I do that? So I'm going to say total, and what do I want to put total for? I want to create a list total of 1, 2, 3, 4, and 5. Those are the values I want to total up, and it says the total is 15. Hey, how is this different from Java code? Not much, because this is imperative style. What does imperative style mean? Notice how I created a variable called sum. What would you do in Java? Int sum equals 0. Okay, to be fair, int sum semicolon. Okay, it initializes to 0. Fine. Then what do? You say for int I. You have to tell int to Java because it doesn't know, right? So you got to tell him, just in case. So int. Here Scala says, don't bother. I know I is integer. How do you know? Based on the context, I know it. So it infers the type. So other than those two differences, it's pretty much like Java code. It's imperative style. But I'm going to write it in a functional style and show you how we could write this. Oh, please, yes?
Normally it's less than or equal to. What's with that hyphen?
Oh, yeah. So I'll come back to this in just 1 second. Look at line number 4. We're constantly modifying this variable. So that, again, is imperative. You keep modifying variable. What is this less than? So that's a good point. Think of this like a for each statement in Java. Right? Java introduced for each in Java 5, right? For is evil in Java. The reason you should not use for at all as much as possible, right? It's a for each is better in Java. Why? Because the for statement requires you to index through, and there's a huge possibility that we said, is it less than or less than equals to? You pause that for thinking for a minute. Anytime there is an opportunity to remove thinking, it's a good thing to do, right? Then we can focus on other things. So even in Java, you don't want to use a for loop. You want to use a for each loop. This is a for each, basically. It knows to pull one element at a time and run it.
Isn't it actually a method call? Like, couldn't you actually write I dot and then put the list in parentheses?
You could do that too.
Just to
Yeah. There are multiple flavors of this available as well. Sure, absolutely. So please.
Will Scala prevent you from assigning something to I? When you do I?
Is assigning to I a good thing or a bad thing?
Well, we talked before. I hate that.
Yeah, I hate that too. So no, it's a val. You cannot assign to it. That's a beautiful question, right? Because wherever things have to be treated as a constant, it will. A parameter, oh, look at list, list on line number 1. You cannot assign to list. If you really squint your eyes, there's an invisible final there. So Scala already does the right thing. In Java, if I do it, I change list, tough luck. We introduce bugs in code doing that. Scala says, no, don't do that. It's a bad practice, right? It doesn't allow you to do that. So wherever things have to be, in most of the cases, if you never told him what type it is, and you never said var or val, you can safely assume it's a final. It's a val. So Scala does the right things most of the time. So that's a good thing. Yes, please.
You still modify the collection under the reference?
Good question. Answer is depends. This list, in Scala, lists are immutable. So you cannot modify it, period. So lists are immutable. But then Scala says, I'll give you 2 sets of sets. I'll give you 2 sets of maps. Those that are immutable and those that are mutable. If you don't ask for one, what do you think it's going to give you? Immutable, right? Because that's safer and that's better. If you want immutable, you got to specifically say, please give me immutable, and it's clearly visible to you that you got an immutable list, or a set rather, not a list, set or a map. So most of the time it's immutable, but then you can also get mutable things for certain select things. Excellent. We wrote a, oh, yes please.
Is Scala's compiler smart enough to apply stuff like, say you put 1, 2, 3, 4, 5, right? So instead of actually going for a loop and just do 5 and 10, then you could just do n plus 1 or 2.
In the for loop you're saying? Or where at?
Instead of doing a for loop,
Yeah.
you could just apply the formula n plus 1 or 2.
No, because the list is not sequential by any means. That we have not. No. Well, if it is something that you can infer consistently, it can. But in these cases, that's not true, so it won't. And no, as a result, it will not be trying to do manipulations at that point. It does a lot of optimization. It is smart, but it's not arbitrarily smart. It is consistently smart, right? So the answer, that's the way I would look at it. Where it makes sense to do it consistently, it will. If not, no. Scala compiler makes use of extensive optimization. So it does know what to do, but it may not do what we think it should do because that may not be consistently applicable in other places. That's where the difference comes in. Now we wrote an imperative style code here, but how do I write this in a functional style of programming? So what I'm going to do now is to write this code in a functional style. What does that mean? I'll tell you what a functional style is later on to a little bit more. But for now, in a functional style, we're going to promote immutability. That's not the full story, by the way, but that's a good story to start with. We're going to say it's immutable. We don't want to change any value once we create it. So it's called assignmentless programming. So how would we do this? So what I'm going to do is I'm going to define total, let's call it functional. And then I'm going to say list is list integer. And what do I do to total these values together? That's my question now. So to total these values, let's assume for a minute, there's a reason why not many people sat in the first row, because I pick on the people in the first row too much. So I'm going to total up the age of these 4 gentlemen. He looks really worried. No, I'm not going to ask for your real age. That's okay. So we're going to total the age of these 4 gentlemen. How do I total the age of these 4 gentlemen? So here's the first rule of thumb. Assume that I have a post-it note with me, but this post-it note has a unique feature. It's a write once post-it note. Once I write on it, I cannot change it. I cannot erase and change it. So on this post-it note, I write a 0, because 0 is the total age of everybody so far. What's your first name?
Richard.
And I'm going to give this post-it note to Richard. So what does Richard do? Richard is supposed to total his age to the age he received and pass it down, right? So what is he going to do? He says, it looks like a 20-year-old guy. What does he do? He takes 20 and adds to 0, and the new value is 20. But what does he do now? Create another post-it note, right? On the new post-it note, he writes 20. What does he do with the post-it note I gave him? Throw it away. This was a revelation for me one morning. I was like, darn it, functional programming will really suck if we don't have automated garbage collection. We kind of toss it out, right? So he creates 20 on this new post-it note. What does he do? Passes it down the chain. Am I making sense? Then what does the next person do? Hey, it's 20 at his own age to another post-it note, passes it down the chain. Making sense? We're going to put that in code. But notice what happened, or what did not happen in this example. We never modified anything. Make sense? So what I'm going to do here is, I'm going to say list.fold left. Fold left is a function that allows you to take the data, and it's as if you're folding or rolling it down. You're performing operation on one element at a time. What is the first value I send? 0, because that's the value I gave to Richard, right? That's a value 0. What does he get? He gets a function where this function has 2 parameters. Please don't worry about the syntax. Focus on the concept. So what does this do? It says I'm going to take 2 parameters, carry over from the previous one, and element, whatever my element is. So now what am I going to return from here? I'm going to return carry over plus element. That's the value that I'm going to return from this particular call. So what would this do then? So I'm going to create a list of 1, 2, 3, and 4, and 5. It better be the same result after all when the whole thing is done. But how is this different? The first noticeable thing here is, notice there is no assignment at all. In line number 10 to 14, I never set a value. When I call for left, I send 0 to Richard. What does Richard get? Richard says, oh, you called me, and you gave me a 0 for carry over, and E is my own value. He adds 0 to 20, returns it. What does the for left do? Grabs the returned value, turns around and calls the function one more time. It's a function, by the way, here, and sends 20 as the carry over. E is the next element in the list. Takes the computational result of it and then carries over. This is a built-in function within Scala for the list, but this is a functional style. I've completely avoided what a functional style is, but I keep saying it. But you can see the difference in the syntax and also the variable being. So on one hand, you notice it's pretty concise. By the way, it can be even more concise than this. But I don't want to go there today. We're going to just be happy with this and move on. This code will just fizzle down to very small amount of code. And you can do it fairly easily in Scala. But I'm not interested at that part right now today. But I'm going to focus on the functional aspect of things here. So what is this functional style I keep talking about? The first thing is assignment-less programming. You're not assigning variables over and over and over. Hey, what good is that? When you assign to variables, you got to worry about thread safety. If you don't assign to variables, you have nothing to protect, so you are much more free to use things. The second benefit of functional style is functions don't have side effect. So what does that mean? Functions don't have side effect. When functions don't have side effect, multiple threads can call that function, and you don't have to worry about messing up. Supports concurrency again. So think of a function as a cylinder. You put some stuff in the top, it gives you the result based on what you sent in. It doesn't change anything outside. Nothing outside changes it. So it is very well behaved. And the data that comes in is immutable because of assignmentless programming. So what's good about it? You got what's called referential transparency. Referential transparency says I can take these functions computations, I could move them around in my code. Gives greater privilege for JIT compilers and other compilers to optimize code movement. But not only can it move up and down, it can use referential transparency to distribute this across multiple cores or multiple processors. It gets to know what can be distributed, what can be computed simultaneously, and you can grab the result and continue on. You can leverage that very quickly. So functions are first-class citizens. What does that mean? Remember how you can create an object within a function? You can create a function within a function. You can create a function anywhere you want to, mostly. So you'd be in the middle of a function, you can create another function. An anonymous function, boom, comes to life. You can do that. You can return functions from functions, like you return objects from functions. You can pass functions to functions, like you pass objects to functions. So then your application can be decomposed not into objects, but can be decomposed into functions. It turns out functions are the smallest grain of granularity, not objects, because objects have collections of functions. We're even smaller than that, functions. So functions become true composition of your system. And functions are higher order, meaning you can put them together to compose a system rather than putting objects together to compose a system. So these are some of the capabilities. How is this going to help? How is it going to change our way of doing things? Let's go back to totaling numbers for a second. So I'm going to say define total, and I'm going to say list. And I'm going to take this list of integer, and I'm going to total these values. So what do? I'm going to say var sum equals 0. And I'm not even using the assignment-less nature here. So I'm going to simply say for list dot for each. Sum plus equals the value that I want to total. So notice how I'm writing it a bit differently this time. And I'm going to return the sum. I'm not using the traditional for loop now. What's the difference? A for is an external iterator. You say, next one please, next one please, next one please. For each is an internal iterator. You do the job of iterating, I don't care. But I'll give you the body of code to run for each element. Right? Now let's say we got this done, and I say print line total, and I'm going to give it a list. Let's say list of 1, 2, 3, 4, and 5, one more, and 6 one more time. And I run this code, it finds the total. I think I'm done, I'm about to leave. My good friend Richard says, Venkat, good try. I want you to provide me one more function, a function that will only total even numbers. All right, Richard, no problem. How do I do that? Write another method. There is a reason why God invented copy and paste. So I copy and paste it, right? And what do I do here? I'm going to say total even. And what do I do here? I'm going to say over here, if the value E is even, then do the total. Make sense? Let's see if that works. So once I finish that part, I'm going to make it work right now. And so I'm going to say total even over here. That's what I want to total. And that should only total the even numbers in this list. And it turns out it did. I'll make it a bit easier on you by moving this up here. OK. So I think I'm done. I'm about to go home. Richard says, excuse me, I need one more thing from you. I want you to total odd numbers. Oh, by the way, I also will need you to total only numbers greater than some number. At this point, wisdom has to kick in. Copy and paste will not improve. Only advantage would be job security, but that's a job you would hate eventually to have, right? This is where Ken Beck introduced this concept called triangulation. So triangulation is where, go ahead and duplicate the code once, maybe twice. But then you see a commonness emerging out of it. Then you pull up the commonality and create abstraction. How do you create abstraction normally in triangulation? Creating a base class, right? But that's heavyweight. It doesn't have to be a base class. Why not just a function that will provide abstraction? So notice what I'm going to do now. I'm going to go back to this code. I'm going to get rid of this total even because we duplicated that. I don't want that. What I'm going to do is total select values. Who's going to select? Richard. He's the one who keeps telling me every few minutes, I want this, I want that. I'm going to give him an engine to select. I will let him decide He tells me the predicate. So notice what I'm going to do now. Here's the list selector. You can call it whatever you want to call it, doesn't matter. What is the list? List is an object. Selector is an object, but it's special. What kind of object do you think it is? It's a function. Those are called function value in Scala. So I say selector, what does he take? Takes an integer. What does he give? See, notice how a function is a mapping of input to output. What do you think he's going to give you? A Boolean, that's right. So it gives him Boolean. Now what am I going to do here? I'm going to simply say I've got a sum here, but if only the selector E accepted it, then do the sum. Notice how trivial this code is. Notice how syntactically it was no ceremony. The day I learned this, I cried that night. I said, it cannot be this simple. I thought this has to take a lot of effort. How could it be this simple? It's got to be complicated, right? No, it doesn't have to be. And so what did this do? It said, I'm going to receive this value, and I'm going to say, if the selector says yes, I will add it, otherwise ignore it. What's a selector? It's a mapping of integer to Boolean, that's all. So now what do? I come down here and say, total select values, because that's the name of our new function here, right? So I say total select values. And I'm going to give him a list, all right. But then after the list, I give him one more function. This function says, I'm going to receive an element E, where this element E better be nothing, because I want to total all the values, true. So essentially, I total all the values. So the code still produces the result it did before. But now I want to total only even numbers. How would I do that? So I'm going to say print line total select values. I said E, but this time E mod 2 is 0. Return the true of that. That is going to end up selecting. Did I mess up?
Give a space between the L and E.
What a picky audience. Fine. Okay, so notice now that it is able to print the 12. But then Richard says, okay, Venkat, but I want you to total only values greater than some number, let's say greater than 4. Guess what I'm going to do? I'm going to simply say value is greater than 4. Or you could say, you know what, let's just make it non-ceremonial. You could say, whatever value you give me, it better be greater than 4. You can make it concise that way too. But what did you do just now? You made the total select values highly reusable. That function said, I'm going to do the totaling, but you are going to tell me what to total. The values and what to select. Again, don't let the syntax bother you. Look at the concept you have on hand, right? That's functional ability to decompose the system into smaller functions.
So again, the thing that kind of makes me feel a little uncomfortable when I'm doing this type of thing is, in terms of testing, when you have the ability to pass in dynamic behavior into a function, testing that function, to me that becomes just like, how do you test every permutation of what they could toss into it?
It's very simple. If we work for a company where we compile code and ship it, we are in trouble. But we have the culture of compiling the code and running it before we ship it, not a big deal. So I'm not of the belief that unit testing is important. I'm of the belief that unit testing is very important in combination with integration testing and functional testing. So you can actually, I would argue this code is even more testable because I can throw in misbehavior into this code by marking this function at a unit testing level, and I can fortify your function, saying your function is rock solid even if I send misbehaving functions. Unit testing can cover that. Then during functional testing, you got different scenarios. You may say, hey, we're doing stock selection, but here's the predicate. Right. He says, no, my predicate is different. He says, my predicate is different. Well, we got 3 integration tests for them. Whereas your functional test says, I'm also going to test for odd conditions that I didn't expect today to happen, but potentially could happen. So you got a double power on your hand. So this actually lends itself even better to testing, but we have to have the discipline to do it.
Yeah, I mean, just from an API standpoint, though, if you're driving an API, you don't know what function somebody's going to pass into it. So,
but this is not a new problem, right? Anytime we use dependency inversion, we've always had the problem, right? So if you really want to close it, you could even here. It's not that you're mandated to write code like this. But if you do want dependency inversion, it doesn't cost you an arm and a leg and a spring to do it. Right? That's the difference here.
It's not that I didn't understand it. Couldn't be.
Oh, I know.
Maybe I was overthinking it, and I think it sounds like.
No, that's a fair question, by the way. And a lot of times, even if I know it, it helps to assert a certain understanding. So I'm not bothered at all with your question. It's a good question to have. Please.
Yeah, does list support immutable element?
Correct. You cannot modify the list, period.
Okay, so that means like in the memory that for every function it calls, it is adding up that immutable elements. It uses up the memory.
It potentially could, right? It potentially could. But doesn't mean that that's the way we're going to do it, right? So this is something very important to think about. You don't okay, if somebody comes to you and says, hey, I know C. I've programmed in C for 20 years. I'm going to go read a Java syntax book and code. What does he do? He writes C code in Java. So what you are saying is, hey, if I create a huge list and manipulate it, yes, but that's not the way we would design the application. So remember how you took about, what, a week to learn Java and then 10 years to know how to design with it, or maybe more? We all do, right? I'm still learning that trick of how to do good design, even though syntax comes quicker. Similarly, designing a concurrent application or a functional application or both is a separate skill we have to spend time gaining. We cannot throw a data structure from a traditional code onto a functional language and say, go do it.
So but that means like it's replicating the data, right?
Like I said, yes, you can make it mess up. Yes, you can make it fail. You can make it suck. But why would you? Right? We would design it so you can leverage it and not make it suck. So we cannot design application the same way with the newer language. This is the story of this guy. You probably heard this story. There was this guy driving on the road, and he saw this guy using a saw. Man, what are you doing? I'm cutting the tree with the saw. Look at all the tree I got to cut. And the guy said, you know what? I've got news for you. Here's a saw. It'll solve problems. You'll cut all this tree in 20 minutes. And he goes away. Next day he's coming back, and the guy is still using his old saw. Hey, what happened to the chainsaw I gave you? Why didn't you use it? Are you crazy? That didn't work. He said, show me how you used it. He took the chainsaw and did that. And he said, oh dear, you forgot to crank it up. This is how you do it. It's like, oh, you didn't tell me that. So absolutely, right? We got a new tool on our hand. We got to use it differently. But that doesn't mean it comes naturally. Give a chainsaw to somebody who doesn't. There are people around you you don't want to give it to, right? But there are people around you who will be able to man it. That's why we have to get trained ourselves for those skills to use it. Then we are more productive. But you cannot just take a chainsaw and give it to somebody who's never used it and say, go at it. He's probably going to cut, but not a wood. Right? So that's why. Yeah, please.
So when you're adding an element to a list and it returns you a new list, does it make use of any sort of optimizations like Clojure does with persistent?
Absolutely. Well, so what happens when you add stuff to a list? Because memory is a concern and performance is a concern, you're not really adding to a list, you're creating a new list. However, that did not go around and copy the entire list also. What it did was, it really created another head. You cannot add easily to the tail because of that performance concern, which again changes the design of your system. But it will create this new element. The new element will point to the head of the old list, and then your list pointer will point to the new head. So the old list and the new list coexist. You say, oh my goodness, what will happen if things change? Because they don't change, you can optimize on these things. Immutability helps you in this field. So good point. I'm glad you brought that up, because that kind of optimization happens as well. But then we also have to do other concerns on top of it so that we don't duplicate our data over and over. Please.
When you're defining the selective, you have to specify specify the type in that method?
Right, good question. So Scala says, as much as possible, I will determine the type for you. But if you are defining a function at a very top level or a root of a tree of dependency, you need to tell me the type. So in this case, I said it's an integer, and that piece of information is required. Scala requires you to do it. You could generalize this. You could write this entire function as generic and say, list of t, and this is taking a t and giving a Boolean. Sure. But you have to specify type at that level. However, notice I never specified the type after that, because there is enough information for Scala to talk about it. Let's talk about that for a minute, if you will. So we talked about the functional style, but let's go to Java for a second. If I say string str equals hello, so I define this as a string. We saw this. Now I'm going to write a Java code. If I say Java array list, I say list equals new array list. And then I say list.add1, and then I say list.add 1.0. We know we're in trouble here, because we're putting all kinds of stuff into this list. You may say, oh, Venkat, this is not a problem. We know already we have a solution for it. What is it? Generics, right? So absolutely, we can put generics. So I'm going to say integer, and then I'm going to say integer over here also, right? Integer. So now the compiler will not compile this line of code. Yeah, we've done it. Or did we? You could do this. You could say array list duh equals list duh dot add 1.0. What will happen? It will compile. It will produce a bytecode. When you run it, what will happen? Potentially a class cast exception when you pull stuff out of it. When you pull stuff out of it, you're going to get a class cast exception. You say, wait. We have generics that gives us type safety. Why am I getting a class cast exception? This is worse than what you had before. Because you didn't say integer once, you said it twice. When you say it several times and they don't get it, what do you think? Java has the intelligence of a monkey. It doesn't matter how many times you tell it, it doesn't get it. So in Java, when they said typing, they meant your fingers. What are you doing? Typing. What are you going to do this afternoon? More typing? Never use these words. Scala is statically typed like Java. That's an insult, because Java is not statically typed, period. It just fooled us, right? It's not statically typed. It's sad. In Scala, var stir equals hello. So I created a hello, and I'm going to say print line stir. So I created it as a variable. I printed it. Now I say stir equals hi. I change it. Print line stir. Notice what I did not say. At no point did I tell Scala you are using a string. I'll be honest with you. When I started learning Scala, I did not write code like that. I wrote code like this. All my Scala code was fully typed with my hands. There was one morning I was getting out of my bed when I suddenly realized, darn it, you've been doing it wrong. And my heart was pounding. How stupid was I? So I ran to my computer, opened up one of my Scala code, and I started removing type information. And I started running the code. While the code was running, Scala was laughing at me. Kid, finally you figured out what I am about. It is not about typing in code, it is about type inference. You type less because it is more typed. In a language that is typed less, you type more. Because Scala is well typed, you type less. You see what I'm saying, playing with the words here, physically typing. You don't need to do that. So now if I say over here, stir equals 1, print stir, Scala says, excuse me. You can't do that. Type mismatch. I found an integer when a string is required. By the way, don't misunderstand this as dynamic typing. This is not dynamic typing. If this were dynamic typing, line number 2 and line number 4 would have run before this blew up. This is a compile time typing. You say, Venkat, where did you type? Where did you compile? Compilation happened. When you run a Scala code, you can run it in one of two ways. You can take a Scala code, you can run Scala C, like you run Java C, and then you can take the bytecode and run it. But if you're writing a small piece of code, you don't have to go through that ceremony. Scala says, I will do that for you. So if you say Scala and the name of the source code, Scala will create the bytecode. Scala is never interpreted. Scala will create the bytecode, grab the bytecode, and run it, so you don't have to spend more time with these ceremonies. Right? So that's what happened here. At compile time, it said this code won't work and pointed to it. So the next thing I want to talk about, we talked about functional typing and style. We also talked about the typing and the capabilities. I also showed you function values. I'm going to only talk just a little bit about pattern matching, not a whole lot. You can do pattern matching to match against various streams of data that come in. Suppose you're receiving a message stream with stocks and trading and symbols. You don't have to sit there and do a lot of work. You can put a pattern matcher. Imagine a pattern matcher like a coin splitter, right? Or coin, what do you call that? You know, coin sorter, right? So you just put coins over it, it falls in the right places. Think of a pattern matcher similar to like that. You put case blocks and it filters nicely. When you write it, the only problem with using that is you won't want to go back and do any other way after that. It's so charming when you do it that way. It's pretty powerful. I'm not going to spend time on it because I want to spend time on other things for you today in here. And I'll show you a little bit of that later on with the XML maybe, I don't know. But I want to talk about traits. How many of you are familiar with multiple inheritance? Okay, a few of us. The others know not to raise the hand. You never say that in public, right? Why don't we like multiple inheritance? Well, because multiple inheritance is like a gorilla. It's so cool and beautiful when you watch it behind the bars in the zoo, but you don't bring it home. It topples everything over, right? And so multiple inheritance is like that. Well, the good news, though, is that multiple inheritance is not a bad idea. It's the implementation of multiple inheritance that's a bad idea in language like C++. We can use multiple inheritance in a very controlled manner, in a very efficient manner, using mixins, or also known as traits in Scala. Let's look at an example here. Let's say I have a class that I want to create human. Within human, I'm going to create a listen method. So listen, and I'm going to say listen, and I'm going to say print line. Let's say you know, something like I am, and I'm going to put a name plus your friend. So what is a friend? A friend is somebody who listens, right? That's what a real good friend is. So a friend has a name and he's listening. So now I say val Peter equals new human, and I'm going to say Peter over here. Now I'm going to say Peter.listen to listen, and I run this code, and Peter listens. But then we realize after a while, we forgot one very important friend. What's that? Dogs. Dogs are the best friend, right? Man's best friend. How do I implement a friendship in dog? I got an idea. How about inheriting dog from human? They don't like it. So tell me, what's the Java way to solve this problem? Interface, visitor, all those concepts, right? Well, we're going to do this a little differently here. Notice what I'm going to do now. I'm going to take this listen from here, remove it from human, and I create a trait called friend. I created a trait called friend with the listen, and name is a string. In other words, this trait requires the object which is going to mix this in have that property. And I say extends friend. Nothing, not much difference, right? So I run that code, and human is still a friend. But the beauty of this is I can pass human to a function that takes a friend. So define seek help, and I say friend, and I'm going to send this friend to this method. So I say listen. Now I can say seek help from Peter. So notice how I'm treating human as a friend. I'm able to send it. But what's the beauty of this? The beauty of this is it's extremely lightweight. And as a result, I can easily say class dog. Let's do it up here. So class dog, actually, let's say animal. Class animal has a name, let's say string. And I say class dog is also having a name, but it extends from animal, and the animal has a name. But then I'm going to say over here, rover equals new dog, rover, and I say rover.listen and seek help from rover. That won't work, obviously, right? Because you never linked dog to the friend. But you know that dogs are the best friend you could have. They never interrupt you. You are going home after a very tired work, you say you got a lot to unload about the day's work. You start talking, the dog intently listens to you, right? So we want to make that happen, please.
Some parameters like human animals, you can remove the type, right?
It depends. It depends on which part it is. But here's the beauty. Don't put the type. Scala will clearly tell you when it needs it. Right? If you're in doubt, don't put it. Scala would say, excuse me, you need to tell me what the type is. So that's the only time you want to put it.
You just said you put so many types. You remove so many types. You can remove the parameter types.
To a certain extent, yes. But you cannot eliminate all the type all the time, because there are some times when Scala cannot figure it out. Right? So you're going to look at 1% of the time than 100% of the time. That's the difference. That's why it's still a statically typed language. Some point you got to specify the type. And you could say, oh, but in other languages that's not the case. Scala says, it's not worth going that extent, because it leads to too much compilation complexity and error rate. So basically what I'm going to do here is I've extended the animal from here, but then I say with friend. So I put the trait up here, and I've said dog is with a friend, and I run it. Now basically in this particular case, what's happening here is, okay, so this is going to override him, because this is a parameter that's coming from the base class. That's what he was unhappy with. So notice how I created a dog as a friend. One more step. I want to create a class, a class cat. Cat has a name, val name, string, extends animal, which has a name. So now I say val snow equals new cat. That's my cat's name, let's say. Now I say snow.listen or seek help and send snow. What's going to happen? It will not work. That's because you know very well cats are not friends. They stare at you. They say, why don't you go back to work? You're bothering me, right? You have a cat, Joel?
No, cat.
He's a wise man. Richard, you have a cat? Anybody has a cat? He says, you know what, this is unfair. He was happy until this point. Now he's offended. He says, this is unfair, right? Well, okay. Cats are still not friends, but his cat is special. So we're going to go to his cat. Notice that. Classes don't have traits. Objects can have traits. I will not talk more about this, but I will just give you a teaser. I use this to create decorator pattern. The decorator just fizzles to a beautiful code. This is something you would frame and just keep looking at it. In Java, if you want to use a decorator or some patterns, you follow a committee and you go through strategies, right? You just do it. It just works. It's beautiful to build decorator patterns with traits. It's just amazingly simple. And you don't even have to have a single concrete class. I like kind of feedback like that, where the music tone rings and says, yep, that's cool. So essentially the point is, you can create abstract classes and then chain them together with traits and get combination of flavors of things without having to write any hierarchy of classes. And then you say, wait, let's run that again. What if you mix two traits together and the traits have conflicting methods? Remember, that's what drove us away, screaming from multiple inheritance. What Scala does is, it does method chaining. So it'll form the trains. That's where the decoration comes in. It forms the chain and passes the method one after the other from right to left. Is it right today? Right to left, right? And so it knows how to connect it together, extremely powerful. So I talked about traits. What I want to talk about next is a little bit about XML. So I want to create a little XML document. So var XML equals hello/hello. Looks familiar, right? Hey, wait. How long has XML been around?
1997.
97. That's what, 13, 14 years?
Still 1.0.
Still 1.0.
Beautiful.
Beautiful, isn't it? If you live in a place for 5 years and don't commit any crime, you're eligible for what? Citizenship. XML has been around for 14 years, and yet it's a second-class citizen. XML says, this is unfair. You put me in a double coat. Why do I deserve it? Why can't I have my freedom and deserve the respect it deserves?
It has been accused of crime.
It has been accused, but those are misdemeanors, not crime like crime. I mean, a little tax flaw, penalties were charged.
He paid it on time.
He paid it on time. Let's remove the shackles. XML is a first-class citizen. X equals 5. X equals XML. Why not? Anybody has a problem with it? See? You're the only one who had seemed to have a problem here. So XML is a first-class citizen. You can put XML in code. You can read XML and process it. It is a built-in, as part of the Scala.xml LM class. It's there. You don't need DOM to process it. You can use XPath query on it. Let's give it a try. So I want to go find out what the weather is, right? And it turns out Yahoo gives me this information. So let's go see if we can find that. So I'm going to say get weather info, and I need to give him an ID, and the ID is going to be a string I'm going to give him. So I'm going to say val URL equals Yahoo weather. As you can see, I type code really fast. So Yahoo gives me this data. I gave him a URL. We'll take baby steps to find it. I'm going to go to Yahoo, assuming my internet connection works, and pull the weather data. So what do? I'm going to say print line get, actually we'll not do that right now. We'll do it a little bit differently. Get weather info for what? For this city that I've got the ID for on hand. Whatever city, we'll figure it out. So then what do? Now that I have the URL, I want to go to the URL and get the data. What do you do in Java for that? New URL object. And then what do? Get input stream. Then what do? Get input reader. Then what do? Get file reader or buffered reader. And then you put around that 20, 30 catch blocks. It's time for lunchtime. Does it work? What do you mean it works? I just finished typing the code. It's a crime to be coding like that, right? It's a waste of resource. I want to go get this. How do I do that? Source dot from URL. Import Scala.io. And I'm going to use XML. Import Scala.xml. So I got the source. And it puts all the data, make string, and I'm going to store it in response. Response equals. Let's take baby steps. Don't mind that, right? Response. So I'm calling this code and saying, go get this for me. And I believe I call this as WOID, which is what I should call this one. No problem. So run this. And what does that do? It should go to the web. And it pulled up the Yahoo web service. 2 lines of code, folks. you still have a problem to deal with. You got to figure out what to do with your free time. But you don't have to spend that typing and having carpal tunnel. That's data from Yahoo right there. What does it say? It says, oh, Denver, place near where I live, or I'm supposed to live. And then it says location, and then it tells me the temperature. I want to pull data from XML. The minute you say that, you'll see a smile on some people's face. Yes, 2 weeks in the timesheet. Especially the consultants, right? They're like, yep. I can not only 2 weeks in a timesheet, I will charge hours in the evening and eat their pizza. So I want to get this data. What do I do? Val XML response equals XML dot load string response. Print XML response. Now what did I do? I went from a string to an XML. Nothing different so far, but it's XML. So now I say, hey, tell me XML response, XPath query, location, XPath query, city. You should know the XML structure, obviously, but that's no big deal. You know it already, right? That's what I want to find out. These two locations, these two details that I want to pull from this. And it helps to print sometimes. Otherwise, you're staring at it. It's like, what's happening? Denver. I want to know what temperature it is right now in Denver. Not yesterday, not tomorrow, now. So what do? Comma, XML response, and I want to know the weather condition, right? Condition, and what I want to know is temperature. And it turns out it's 33 degrees, folks, above freezing. It's a warm day. It's warm. Denver, 30 is warm, by the way. Yeah, believe me. Tell me, 3 lines of code equals productivity. If you want to write this in Java, you could. But the cows have gone home. See, I like that music. This is a great group to, I love it. You got real people with skills here, man. So, absolutely, right? Don't have to do that. No need to write a lot of code when you can get things done quickly like that. That's XML as first-class citizen. Merely scratching the surface here, obviously. It's a lot more you can do with it, right? But now that I've gotten this, let's see what we can do. I want to go through multiple cities and get this information so I can take you to concurrency a little bit. So what am I going to do? I'm going to say, let's do for some integer ID in the range of that. I don't even know what these numbers are. 2, let's say 9. I don't even know if these are valid numbers, but who cares? I'm going to go through this list. I'm going to ask him to get me the details for each one of them. I'm going to change it a little bit. I'm going to return not print it, but return it. That's a tuple. I'm just returning the tuple. Tuple is beautiful. It is just collection of data, lightweight collection of data, which is immutable. Those are great candidates to exchange across multiple threads because they won't get modified anywhere, right? So now what am I going to do? I'm going to simply say here, for this list, I'm going to print line get weather info id.toString. So I'm going to ask him to go out and get this data for me for each one of those cities in that list, one at a time, and display it. It all seems to be Denver.
Historical data.
Because different zip codes and stuff like that. Actually, you know what?
Ghost City.
Huh?
Ghost City, too.
The Ghost City. Yeah, where it's frozen. Actually, they're all Denver, by the way, but not the same Denver. So it would be nice to know a little bit more, right? So notice what I'm going to do here. Copy that and say region. So we can know where in the world all those Denver come from. That's the shocking news that there's actually more than one Denver in this country. Talk about namespace collision. So now what's happening here? It's taking time. Spinning the wheel. Come on, you can do it.
I think the ghost town doesn't want you to know what region.
Yeah, that's right. That's for sure. That's probably the case, right? It doesn't have a region. I don't know what happened there. Bug. Fix it. Yep. So we can go through and that's probably a little delay in getting the signal. I don't know what it is. We'll see. So you can loop through and get all these data, but the problem, as you can see, is it could be slow. Hey, there you go. That took a long time. But apparently there's a Denver in Ohio. Two of them, yeah. One is not enough. There's one in South Carolina. That's the place to go. Colorado, maybe that was a different Denver at the time then when I asked for it. It's really a warm day.
It's Ohio.
Ohio, yeah.
So why is it showing up twice though?
2 zip codes most likely. Those IDs are zip code IDs. It's quite possible that there are multiple IDs nearby. So if you ask for the zip code, you'll notice it's different. The thing is, okay, this is going to take a little bit of time, but I want to speed this up. I want to make this concurrent. Should we do it? All right, let's do it. So I'm going to put a little delay here to see it. And it is already slow. Maybe I should not put a delay. If it gets fast, we'll slow it down. Okay. So let's say start equals and system dot nanotime.
Premature de-optimization?
Yeah, exactly. Premature de-optimization. Yeah. So end. And I want to know how much time it took. So let's say time and plus end minus start, and this is a nanotime. So this should take, it's got about 10 cities. Even if it takes 1 second, it should take 10 seconds, but we'll find out how much time it took in seconds when it comes back. 9.4 seconds at the very bottom. All right? We're going to make this faster, but without making it inaccurate, incorrect. And who's going to keep count of number of lines of code I'm going to write? You'll do it for me?
Sure.
All right. Can we trust him with the count?
If you move the line numbers over, I can count.
Okay. So we got about 22 lines of code now. Okay. So here's what we're going to do. See if this makes sense. I'm going to first of all say import Scala.actor and import Scala actor dot star or underscore. Are you counting those 2 lines, the number of lines of code?
Yeah.
Not fair, man.
Got to, sorry.
Okay. All right. So we import. Yeah, we imported those 2. So what's an actor? An actor is a thread that has its own built-in message queue. An actor is a thread that has a built-in message queue. You can send messages to actors and you never get blocked. You can receive messages whenever you want to and process it. When you receive a message, it runs in your local thread, no collision. Only thing you protect is what you send across the threads doesn't collide with each other. Send immutable objects, you're good. What about visibility? What about thread safety? What about concurrency? No worries about those things, because Scala takes care of all of that behind the scene. Your synchronization model just got simplified. So what am I going to do? See if this makes sense. If it doesn't make sense, ask me right away, because it doesn't get better. So what we're going to do is this. I'm going to first loop through this, and I'm going to ask him, hey, go get the stock prices. So what am I going to do? This 4 or 5 guys in the front row are eager. I'm going to give each one of them a city name and say, go to Yahoo and find the data, right? So those are my actors, let's say. So what am I going to do? I'm going to say actor, and I'm providing a function value, as you can see, and I say go at it. Let's assume I'm not even interested in printing it out for a minute. You could, but that's not what I want to do, let's say. So notice how I asked them to go get it. So I could put them all in one line of code if I wanted to, because he's staring at the number of lines of code. I could do that. So all that I did was I said, actor, please go find this weather data for me. Well, there's one problem. They all go find it, and then what did they do? They tossed it. Excuse me, when you're done, could you please text it back to me? So I got to give you my reference, right? So notice what I'm going to do here. I'm going to say caller equals self. Remember what this is? This is a reference to your object. Self is a reference to your actor. So every code runs within an actor. So what am I going to do now? I'm going to say caller, but you got to send the message to caller. There's a very highly intuitive method called bang. So you bang the method over to him. We're almost done. We need to receive the data when it's done. So I'm going to loop through one more time. You could loop through 10 times or whatever, doesn't matter. So that number is not needed. But what am I going to do here? I'm going to say receive case message, print message. So we're going to receive it one at a time as it arrives from those actors. If you don't want to have a live lock, I could say receive within, let's say, 3 seconds, or whatever that is reasonable for you. You can put that number over here. So basically, what did we do here? We asked him to go out to the web, look at all this data, come back to us when the response comes back, and there was one timeout. But notice it finished within 5 seconds instead of 9 seconds in this particular example. I don't know why there was one timeout. One thing didn't come back in 3 seconds. Maybe we can favor him a little bit more time and say, go get it. So that is an example of, you see how the time is different. Maybe I could put a delay there and you can see it more prominently. But you already see it. It felt that way, right? So you could, at least a 5-second delay in this case. So this is an example of how you are able to send off these requests and then receive this data in a concurrent manner. You can do more work here, so many times out.
So each request is sent out in a different thread?
Exactly. Each request is sent out in its own different actor. Not a thread, an actor, because an actor is a bit more than a thread in here, because you could have thousands of actors, but only a few 100 threads. So these are threads with message queue from the thread pool.